Hello everyone, in this video we are going to see the total and causal order in distributed system. So everyone must see the M1 before the M3 as in the first in first out algorithm. We can see here the M1 gives a message to the M2 and it's transferred the message to the each process like P1, P2, P3 and P4 and at its state to the M3. So from that M3 the physical time is calculated and timestamp also created and it send this to the process 2, process 4 and process 3. So from process 3 the timestamp is shared to the M3 and M4 towards the process 3, process 2 and process 1. This is how the physical time is synchronized. So to start with the receiving algorithm for first in first out multitask and replaceable sequence number with the vector clocks. Some care needs with the dynamic groups. So here in this example we can see M1 receives to the M2 but the P2 sees the M2 before the M1. To be correct, must hold back and delay in the delivery of the M2 and P1. So M3 as in the FIFO, M1 before the M2 due to happens before. Total ordering. In this total order, the messages received from 100 to the receives to the P3 to the process 3. It carries the M1 and the M2 receives a message and carries to the P2 and P1. So the P1 has the value of 1, 1, 0. So from the P3 the message is delivered to the P1 process. So have the 2, 0, 2. So must be hold back from M2 until the missing event seen. Once the M1 is received, can deliver M1 and then M2. So some of the points are sometimes we all want to process to see the exact same first in first out sequence of messages, particularly for state machine replicants. One way is to have can sender token or is to dedicate the sequence process can also build on non first in first out total order multicasting by having the process generates themselves and resolving the ties.